Solidity code that we work with, when we hit compile, it actually compiles down to this Ethereum virtual machine specifications. We'll learn more about those specifications later. And last but not least, another huge congratulations on your first contract here. Awesome. All right, let's get started on our lesson 3. Remember, everything is in the GitHub repository, and we can scroll down, hit lesson 3, and see all the code here. I'm building up this repo as I film, so underneath this lesson 3 is going to be a lot more information than just the code here. All of our code samples end with -FFC, which means -free code camp. So if you see a GitHub repo that ends with -FFC, know that that repository is associated with this course. I'm going to do a quick high-level walkthrough of what we're going to be building in this lesson. So you don't need to code right now, just sit back, watch, and enjoy. In this lesson, we're actually going to expand to having 3 different contracts. Let's say we want to be able to deploy simple storage contracts from a contract itself. Yes, contracts can indeed deploy contracts. We are going to create a contract called storagefactory.sol that's going to be able to deploy and interact with other contracts itself. So what we could do is we could go deploy this to a JavaScript VM. We're going to choose Storage Factory, and we're going to go ahead and hit deploy. In our contract down below, we have a number of different functions. Our top function is this function called create simple storage contract, which we can click and it'll actually create a simple storage contract for us. Then we can go ahead and interact with it. At index 0, we'll save a favorite number of 1. Now, if we hit sfget 0, we get 1 back, and we can see the address of the simple storage contract that we just deployed. Additionally, we're going to learn about a number of Solidity features, such as importing, inheritance, and so much more. So let's go ahead and jump in. And remember, all the code is available here from the GitHub repository, so be sure to refer back to these contracts if you get lost. So here we are back in Remix, and we have our simple storage.sol. If you skipped over the last section, be sure to go to the full blockchain Solidity course.js and scroll down to lesson 2, welcome to Remix, and grab this code, go to simplestorage.sol, and copy paste this code into Remix, because this is where we're going to be starting from. We have this simple storage contract, which is great. It allows us to store a favorite number, and it allows us to store favorite numbers across different people in both mappings and arrays. But let's say we want to get even more advanced with this. We actually can have a contract actually deploy other contracts for us, and then go ahead and interact with those contracts from other contracts. Contracts interacting with each other is an essential part of working with Solidity and working with smart contracts. The ability for contracts to seamlessly interact with each other is what's known as composability. Smart contracts are composable because they can easily interact with each other. This is especially awesome when it comes to things like DeFi, where you can have really complex financial products interact with each other incredibly easily, since all their code is available on chain. So we're going to learn how to do that. So let's keep our simple storage contract exactly the way it is. We're going to create a new contract called Storage Factory. So we're going to hit the new file button and type in storagefactory.sol. And let's close this off for now. So let's go ahead and get this contract set up. From what we learned before, first thing we're going to want to do is the SPDX license identifier, which we're going to do MIT. And then the next thing we're always going to need is our Solidity version. So we'll do pragma Solidity, and we could do 0.8.7. But for this one, let's do 0.8.0 and then just add the caret, meaning any version of 0.8 point something will work. And then let's add our contract name, which is going to be Storage Factory. Now hit Command S or Control S, or go to the Compile tab and hit Compile, and boom, we have our regular setup here. Now we want to create a function that can actually deploy our simple storage contract. So we'll create a function called function create simple storage contract. We'll have it be public so anybody can call it. We'll have it deploy a simple storage contract and save it to a global variable. But before we can do it, how can our storage factory contract know what our simple storage contract looks like in order to deploy it? If our storage factory contract is going to deploy simple storage, it's going to need to know the code of simple storage. One way we can do this is we can actually go to our simple storage.sol and copy everything underneath pragma solidity and down and paste it into our storage factory.sol underneath our pragma solidity. If we go ahead and compile and save this, it actually works. Our storage factory.sol contract actually now has two contracts in it. It has the simple storage contract and it has the storage factory contract in it. If you actually go to the deploy tab and scroll down to deploy while you're on the storage factory.sol, not the simple storage.sol, on storage factory, you can see that you can actually choose which one of these contracts to deploy. A single file of Solidity can hold multiple different contracts. Now that we have our simple storage.sol in our storage factory, we can actually go ahead and create this function to deploy a simple storage.sol. We're going to create a global variable the same way that we would create any other global variable. We'll do the type, which is going to be type simple storage contract. We'll give it a visibility, a public, and we'll give it a variable name. Type simple storage contract, going to be public. The name of the variable is going to be simple storage. Now in our function create simple storage contract, we're going to say simple storage equals new simple storage. This new keyword is how Solidity knows, okay, we're going to deploy a new simple storage contract. So we go ahead and compile this. We'll go to the deploy tab, make sure we're on the JavaScript VM. We'll scroll down to the contract and we'll choose storage factory. And remember, you need to have storage factory.sol selected in order for that to show up. Storage factory. We'll go ahead and hit deploy. And now we see our storage factory contract has two buttons. One is create simple storage, and the other one is going to be a view of our simple storage contract. If we click it right now, it's going to show us that it's currently at address 0 because it gets initialized to being blank. It's saying there is no simple storage contract currently deployed. Now, if we pull up our console and click create simple storage, we see we created a new function call, storage factory.create simple storage contract. And in doing so, we called this function, which created and deployed a new simple storage contract. We can now see what address the simple storage contract is at by clicking the simple storage button, and we see the address associated with it. So now we know how a contract can actually deploy another contract. But the thing is, having this massive chunk of code above our storage factory is a little bit redundant, especially since we have our other file called simplestorage.sol. And let's say we have a contract that has got a ton of other contracts in it. Always copy pasting all these contracts is going to be a lot of work. So instead, what we can do is use what's called an import. So let's go ahead and delete our contract simple storage. And now we're just going to type import dot slash simple storage dot sol. This import dot slash simple storage dot sol is the exact same as our copy pasted version of simple storage dot sol. It takes the path of another file. It takes the path, package, or GitHub, which we'll get to in a minute, of another file, and says, okay, we are going to paste that contract into the top of this contract here. And we actually see, if we go back to compile, we go to deploy, let's delete our old contract. We can actually see storage factory.sol again. We can deploy it, click the drop down, and once again, we can run those functions exactly the same. Importing our contracts like this is much nicer than always copy pasting the code. This way, if we want to change something in simple storage, we have one canonical place to go ahead and change it instead of having to change it in multiple different places. Now, additionally, you'll notice the pragma solidity. If we have our contracts in two separate files, we actually can have different versions of Solidity. Right now, our storage factory has caret 0.8.0, which means that anything within the 0.8 range of this contract is okay. But for simple storage.sol, it says anything in the 0.8.8 and above range is okay. So if we were to try to change the compiler version to 8.5 and then go ahead and compile, Remix is going to automatically bump it up to a better version that is compatible with both of them. In this case, 8.13. But if we, for example, changed our Solidity version of Storage Factory to 0.7.0 and then tried to compile them, we actually end up getting an issue. Parser error. Source file requires different compiler version. This is because our storage factory is saying, hey, anything in the 0.7s is okay. However, our simple storage is saying anything in the 0.8.8 and above is okay. So those two versions are not compatible. So what we need to do is we need to make sure our versions of Solidity are indeed compatible. So let's change the version back, recompile, And now we're looking good again. Now, since we have this create simple storage contract, every single time we call it right now, it'll just replace whatever is currently in our public simple storage variable. Let's go ahead and update this so that we can actually keep a running list of all of our deployed simple storage contracts. So instead of having this be a single variable, we'll make this a simple storage array or list, public simple storage array. Now, whenever we create a new simple storage contract, instead of saving it like this, what we're going to do is we're going to save it as a memory variable by saying simple storage equals new simple storage. And we're going to add this variable to our simple storage array. So same way we did it before, we're going to do simple storage array dot push simple storage. So I should spell storage right. Let's go ahead and compile this. Looks good. We'll deploy the storage factory. Deploy. Click here. We now have a simple storage array view button. We'll do create simple storage. Now we can view the simple storage contract at 0. Right now there's nothing at 1, but if we create another simple storage contract, we can see the new simple storage contract address at index 1. All right, so this is great. We can now keep track of all of our simple storage deployments, but how do we actually interact with them? Let's say we wanted to be able to call the store function on all of our simple storage.sols from our storage factory. You can think of the storage factory as almost like a manager of all of our simple storages.sol. Let's create a new function that can do exactly that. So we'll create function and we'll call it SF store, which is going to stand for storage factory store. And it's going to take a uint 256 simple storage index and a uint 256 underscore simple storage number. It'll be a public function as well. Now, in order for you to interact with any contract, you're always going to need two things. And we're going to refer to this a lot. You're always going to need the address of the contract and the ABI of the contract. The ABI stands for Application Binary Interface. The ABI will tell our code exactly how it can interact with the contract. We'll go deeper into ABI as we move on, but if you go to your compile tab, you hit compile and things are actually compiling, you can scroll down and you can see compilation details and you can see a whole bunch of information on your different contracts. You can see the name of your contract, which for our simple storage contract is simple storage. You can see a whole bunch of metadata like the compiler, the language, output settings, all this other stuff. You can see the exact bytecode and the opcodes, which we'll talk about much later. But you can also see this ABI. This ABI tells you all the different inputs and outputs and everything you could do with this contract. For example, in our simple storage, if we look at the 0th index of our ABI, we have a function add person. If we look at 1, we see our name to favorite number. If we look at 2, we can see our people. 3, retrieve. 4, store. It tells us all these different ways we can actually interact with our contract and the different functions that we can call. We know where our addresses are because we're storing them in this array here, our simple storage array. We can also get the ABI because we're importing simple storage.sol. When you compile simple storage.sol, as you saw in the compilation details, whenever you compile it, it comes prepackaged with the ABI. We automatically get the ABI just by importing it like this. In the future, we'll see other ways that we can actually get ABIs really easily. So to call the store function on one of our contracts, we're first going to need to get that contract object. So what we can do is we can say simple storage variable named simple storage, variable named simple storage of type simple storage is going to be equal to a simple storage object. And instead of doing new simple storage like we did last time, we're just going to put the address of this simple storage object in here, which again, we can get from our array. And in this function, we're passing the array index. So we can say simple storage contract at address, simple storage array at index, simple storage index. This bracket notation here is how you access different elements of arrays. So if we want the 0th element of our list here, simple storage index would be 0, and we pass it into this bit here, and then that'll give us the address of our simple storage contract, which we pass into simple storage here. Since this is an array of simple storage contracts, we can just access that simple storage contract using the index. So we would say simple storage array at index underscore simple storage index. Now we're saving the contract object at index simple storage index to our simple storage variable. Our array here is keeping track of the addresses for us, and it automatically comes with the ABIs here. If this was just an array of addresses of the contract objects instead, we would have to wrap the address in a simple storage object like this. But we'll get to that much later. So for now, all we have to do is this, and we now have a simple storage contract object. Now that we have it, we can call our store function on the simple storage contract. So we'll call simple storage.store, and we'll store the simple storage number to it. So this is perfect. And if we were to deploy this right now, though, we wouldn't be able to read this store function. So let's create another function that can read from the simple storage contract from the storage factory. So we'll create a function called sfget, which stands for storage factory get. It'll take a uint256 underscore simple storage index. This will be a public view function, since we're just going to be reading from our simple storage contract, and it's going to return a uint256, and we'll say simple storage equals, we're going to use this same syntax from up here to get the contract, simple storage array at the simple storage index, and then we're going to do return simple storage dot retrieve to get that number that we just stored up here. And I should spell retrieve correctly so we get no issues. Perfect. So now we'll compile, we'll deploy JavaScript. We're working on a fake account. We're going to use our storage factory. Let's go ahead and delete all the contracts we have so far. Let's go ahead and deploy, hit the drop down. Great. Right now, if we do sfget at 0, we're going to get nothing. Simple storage at address 0 is going to be nothing. Let's create a simple storage contract. Now at simple storage list, we get an address at 0. If we hit sfget right now at index 0, we get 0. So let's store a value on this contract here. So the index of that contract is 0. So we're going to pass 0 as a simple storage index, and we're going to save the number 7. So we'll go ahead and do sfstore. And if we did this right, this is going to store the value 7 into this contract. So if we do sfget of 0 now, it does indeed return 7. If we do sfget of 1, we're going to get nothing's going to happen, and we're actually going to get this revert error here. So let's create another simple storage contract. Now if we do sfget of 1, we get 0 because we're going to get that default value. Let's go ahead on the simple storage contract at index 1. We'll store the number 16. We'll hit sfstore. Now we'll do sfget of 1, and we get 16. Feel free to pause right now and play around with this so that you really understand it. The quick recap is our storage factory contract allows us to create simple storage contracts. It then saves it to our simple storage array, which we can then call different functions on. We can store values from our storage factory contract, and then we can read values from our storage factory contract for any of the simple storage contracts that we've created. This is incredibly powerful. We can additionally make these two functions even easier. We can call the retrieve function directly on this. When we call simple storage array, and then we add these brackets and add the simple storage index, this returns a simple storage object. So what we could do is we could actually delete this whole part and just do .retrieve right here, and then delete this line and say return, and just have it be just like this. If you go ahead and save or hit compile, you'll get the green check mark there. We're calling the retrieve function on whatever this is, and whatever this is a simple storage object. So perfect. We can do the same thing up here by deleting this part and just doing .store underscore simple storage number. Ta-da! We save it, and this will work exactly the same. Awesome. We now have a simple storage contract that can store variables and a storage factory contract that can be almost like a manager of these simple storage contracts and deploy and interact with them themselves. This is fantastic. Now, let's say that we really like the simple storage contract, but it doesn't do everything that we want it to do. Maybe we want it so that whenever we actually store a value, it doesn't store the favorite number, it stores the favorite number plus 5. For some reason, you want a contract that everyone's favorite number is 5 numbers bigger than what they think it is. But you really like everything else that this contract has to offer. Let's create this new contract and we'll call it extra storage. So we'll say extra storage.sol, and we'll create this new contract. We're going to set it up the exact same way we normally would. SPDX license identifier, going to be MIT. We'll give it pragma solidity, and we'll just do 0.8.0 with the caret, and we'll say contract extra storage, like so. If you save or compile, you'll get the green check mark. So what could we do? Well, the first thing we could do is we could copy paste all this code back into here and then modify our extra storage contract as we see fit. This seems a little bit redundant and a lot of work though. So what's another way we could actually get our extra storage contract to be like our simple storage contract? Well, this is where we can do something called inheritance. We can have our extra storage contract be what's called a child contract of our simple storage contract. And we can have extra storage inherit all the functionality of simple storage with 2 lines of code. So first, in order for our extra storage contract to know about simple storage, we once again need to import it. So we'll say import simple storage.sol, and we'll say our contract extra storage is simple storage. And we save or compile. Now our extra storage contract is going to be the exact same as simple storage, and it's going to do what's called inherit all the functionality of simple storage. And we can actually even see that. Let's go ahead and make sure this is compiled. And we'll go and deploy this. And now in our deployed contract, we can see we have extra storage deployed with all the functions that simple storage has. If you want a contract to inherit all the functionality of another contract, you can just import it and say your contract is that other contract. Now we can add additional functions to our extra storage contract that'll include all the functionality of simple storage. Now, let's say that we inherit simple storage to extra storage. However, one of the functions in simple storage we don't really actually like. So if we go back to our simple storage contract, our store function, all it does is take a favorite number and then it assigns the global favorite number to whatever new number that we give it. In our extra storage, we want the store function to do something different. We want it to add 5 to any number that we give it. How can we achieve this? Well, we can do something called overriding the functions. And there are 2 keywords that we're going to use. Those are virtual and override. Right now, if I were to try to implement a store function for extra storage, let's see what happens. We'll say function store uint256 favorite number. It'll be a public function. And let's say, instead of just storing favorite number, we'll say favorite number equals favorite number plus 5. If we try to compile this right now, we'll actually run into 2 different errors. First one is going to say overriding function is missing override specifier. If the parent contract, which in our case is simple storage, has that same function, we need to tell Solidity that we're going to override this store function. And instead, we're going to use this store function. But additionally, we get this other error saying trying to override non-virtual function. Did you forget to add virtual? In order for a function to be overridable, you need to add the virtual keyword to the store function. Now it can be overridable. However, if we save and compile, we still have this issue. Overriding function is missing override specifier. And then all we need to do is add override to our store function. Now, if we save, everything compiles correctly. Let's go ahead and deploy this. Let's delete our old contracts. JavaScript VM, write account. Great. We're going to choose extra storage. Let's go ahead and deploy. And here's our extra storage contract. Right now, if we hit retrieve, we get 0. Previously, our store function would store the exact number. However, if I were to store 5, it'll store 5 plus 5. So we should have 10 stored here. Let's go ahead, call store. Looks like that went through, and we'll hit retrieve now, and we do indeed see 10 is in here. So this is how we do inheritance, and we override functions. And that's it for this section. You've just learned a ton of incredibly powerful Solidity for having multiple files. Let's do a quick overview of what we learned. We learned that we can actually deploy contracts from other contracts using the new keyword. We learned that we can actually import other contracts into our contracts and into our code using the import keyword. And the import keyword is the same as copying and pasting that file to the location of the import line. We learned that we can interact with other contracts as long as we have the ABI and address. We didn't learn too much about the ABI, but we'll learn more later. We learned that if we want to create a child contract and inherit the functionality of some other contract, we can use something called inheritance. And the way to inherit functionality is using the is keyword and saying our contract is some other contract. However, if we want to change some of the functionality of the parent contract, we have to override that function. And additionally, we have to set the function we want to override to virtual. Now we can have our own store function do whatever we want it to do. That is the end of this lesson. Once again, give yourself a huge round of applause, a pat on the back for making it this far and for finishing this section. You're getting more and more advanced with Solidity so quickly. So be sure to celebrate the little wins by getting some ice cream, maybe going for a walk or tweeting about it or posting on Reddit. Congratulations.